Web Assign 8, Question 1, Part B. Let's tackle Part B of this question. In my case, I have iron 2 sulfate paired with potassium chloride for Part B. And once again, like we had done in Part A, to write the products, we're just going to look for novel combinations of ions. As you know, in any ionic compound, the positive ion or cation is always listed first, and the negative ion or anion is always listed second. So we have iron 2 and sulfate, we have potassium and chloride. The novel combinations of ions would be potassium paired with sulfate. Now, why did I put a subscript 2? Well, I know that potassium ion takes a +1 charge because it's a group 1 metal. Sulfate takes a -2 charge because I know my polyatomic ions. The other novel combination of ions would include iron 2 ion paired with chloride. In determining what's aqueous and not, anytime you have a reactant, it is automatically aqueous, and even the question stem will show that there's an AQ behind each of the reactants. To consider the products, well, in the case of potassium sulfate, there are two solubility rules that would catch that. Rule 2, which states that group 1 metal salts are soluble, and Rule 4, which says that sulfate salts are soluble. In that case, both rules reinforce each other to make this species aqueous. For iron chloride, I would look to Rule 3 of the solubility rules, which says that halide salts, which would include chloride, are aqueous. There are some exceptions to that rule, but iron ion does not fall into them. So we have another aqueous product. Now, even without fleshing out the rest of the equations, I know that if I have two aqueous solutions reacting together into new combinations of ions to form other aqueous solutions, then there's not going to be a precipitation. And if there's not a precipitation, then there's going to be a no reaction. However, let's go through this to prove it. And there's an interesting way, there's an interesting point at which it becomes really obvious. So to complete the balanced molecular equation, you'll notice that we need to add a couple of coefficients. We need a 2, oops, we don't need that one. We need a 2 in front of the KCl, and we need oh no, that's it. I'm trying to get rid of my, the 2 in front of the K2SO4. I'll cross it out. You don't need a 2 there. Just the 2 in front of KCl. In order to write the complete ionic equation, we would break apart anything that is both a strong electrolyte and aqueous. Everything in this equation is an ionic compound, which means it's a strong electrolyte. And furthermore, everything is aqueous. So in this case, we're going to break apart every single compound and write it as individual ions. So iron 2 sulfate becomes iron 2 ion and sulfate ion. Potassium chloride becomes potassium, and notice the coefficient 2 applies to the chloride ion as well. On the product side, we have 2 potassiums. The subscript made that a 2. So we have, notice that the subscript 2 can give you a coefficient 2 in the complete ionic equation, as well as a coefficient directly making a coefficient 2 in the complete ionic equation. And lastly, we break apart iron 2 chloride. And we have a nice complete ionic equation. Notice that every single thing we wrote crosses out precisely with another ion. Well, the reactant side crosses out with something on the product side for every single ion. So what do we have left? Nothing. There is nothing that remains, and so we have a no reaction for this chemical equation. Formatting issue that we should point out. In WebAssign, if you have a no reaction, up at the top it said type NR. If no reaction occurs, type NR in all the answer boxes for that reaction. So what we need to do is write NR both in the coefficient boxes and the formula boxes for every single thing in part B of this equation. Anywhere you see a box, just type in NR and then hit submit, and it'll like you for that. It'll give you the green check mark. My stylus isn't super fine grained, but you can see what I'm trying to do here. Typing in NR for every single box in part B. See you in part C.